So Thomas, come up here, because you're going to tell them. I'm human, I make mistakes. Let's give him a clap. Thomas, what would it say again?
Yeah, so
it's about simplicity.
We had a lovely chat before we came on, and I'm not here to dance, alas, but
shall
more
we?
No, we can dance, but later. No, so my phrase is just a very simple quote, which is get things as simple as possible, but not simpler than that. I think that's the main line.
Simple as possible, but not simpler than that. I'm sure he will explain all. Please clap your hands for Thomas.
Hi, hey, good afternoon. You all good? The food here is phenomenal, actually. It's my first time in Budapest. I'm very grateful for the organization for inviting me. I love the food, and I more than love the palinka. I had a little bit too much palinka late last night, so let's see if this goes well or not. Hey, so I'm here today to tell a story which is about how Peak, and I will explain a bit more what Peak does, but we are a brain training app on the App Store, how we became what we are today. My talk will not be at the same very high level as some other talks in the last 2 days. I think what I want to impress upon you guys is more what I think are some lessons that you need to take home with you tomorrow if you go home about how to grow an organization that is quite small with the set of sophisticated data analytics tools that you have at your disposal right now. So that's the idea. The main message is sustainable growth in any business organization or app company out there, it needs to be data-driven. And I hope I can leave you at the end of this talk with some better idea of what it actually means, in a simple way, of course, as we just said. So what I'm going to do is I'm just going to say a few words about Peak, about what we do, about what our point of being is, what our mission is, as the guys from TransferWise put it so nicely. Then I'm going to talk a little bit about what I think the data that you need to grow is and what you need to do in order to grow. I give some examples from Peak, how we do growth hacking at Peak, how we iterate on our message, how we make sure that everyone is on board with all of that. And then I try to extrapolate that into some cultural lessons, into some more general lessons that you can take with you. So first and foremost, Peak. We are an app on iOS and Android, and I hope all of you guys will experiment with us after this talk is done. We've been around for about 3 years. We're based in central London, team of about 40 people at the moment. Our idea is that we believe we can make games for everyone, young and old, that are good for you, that you feel good about playing them, good about training for them, good about competing on them with your friends, and so on and so on. The way we do that is that every game we have in the app itself, about 45 of them, they all track, train, or test for different cognitive skills. So think of something like a Sudoku. You don't feel guilty when playing a Sudoku. This is the sort of thing we want to achieve with all of our games inside of the app. The games are about a minute and a half. You can play them while waiting for the bus or while waiting for the train, like this morning. You can just kind of iterate on them and so on and so on. Some of the games train for emotion skills, others for language skills, others train or track for problem-solving capabilities, for focus capabilities, that sort of stuff. A very wide array of things that they touch on. We are right now the global leader, the #1 in cognitive training, in brain training games. We have just over 35 million users on both iOS and Android. We're mobile only, so we don't have a website, which is important in terms of what data we can capture, of course. And we're just a lot of fun to play, so go and check us out. Now, we focus massively on making the whole experience of brain training and that sort of stuff, making it as fun as possible. But apart from that, we also deliver a lot of data to make sure that you can track what your progression is, you can track what your scores are in relation to your profession or other professions or your friends or something like that, and we kind of try and tell you what you can achieve by playing more of our games. In order to achieve that, we iterate and we focus on just 2 big metrics. Now, the reason that we have to focus really on those metrics is because we're a small company at the end of the day. We're not a big company like TransferWise or whatever, so we have to be very careful in selecting what we can focus on. And like most apps, obviously we focus on retention, on making sure that people who download the app actually come back after installing. That's always a good thing. And because we also need to have a sustainable business, we also focus on providing our users with a pro subscription that they can use to access every feature in the app, to play every game that they want, and to get access to even more feedback on how they perform. Retention and conversion, they also feed in each other because you need to retain people first to tell them what the game is about and how they can play it and what they can achieve from it before you can even start to think about convincing them to convert to pro user. It's a super simple business model. Free users, pro users, we don't have a lot of in-app purchases. We just, once you pay your $2 or $3 a month for pro, that's it, you have access to all the features. And actually in the last 3 years, since we've been on the App Store, we have grown quite sustainably, month on month, 5 to 10% growth, and so on and so on, both in registration, so all users, and in paying users. And that's why I get back to my initial message, which is that sort of sustainable growth needs to be data-driven. So how do we do it? I mean, it's all fine and well, but how did we use data to grow like this? This is a lovely slide made by a company in the US who helps small early-stage product companies with their analytics and how to set up their analytics. And it actually tells you what you need to focus on if you start your company, whether you're 5 people, 10 people, 20 people, 30 people, and so on, how to kind of stack all the different levels of sophisticated analytics on top of each other to achieve the real data-drivenness that you want to achieve. And the main point that I want you to take away from this graph is actually all of these tools are super sophisticated. And that's, I think, the data revolution that's important for me in the 2010s. Of course, we have a lot of deep learning and AI revolution to talk about as well, but the most important thing for small companies that happened in the 2010s is that small companies have access to big analytics, to sophisticated analytics, to very data-driven decision-making in product engineering, design, and so on and so on. And that is a huge difference with how it was only 20 or 30 years ago. Let's take a small step back and let's think about how tech has changed in the last 20 or 30 years. And maybe one of the kind of examples that comes into mind is, certainly for us, app distribution. It's a lot easier than it used to be, right? It used to be the case that you had to have a distribution network, you had to print cardboard boxes, you had to ship your software to dealerships and so on and so on, and then once you wanted to roll out an update, you had to reprint all of the CDs and ship a new version of that, right? In 2000s, it became a little bit easier, but now it is so easy to just roll out a new update or roll out a new app. Anyone can do it from a computer, right? Second big thing that changed is it's running a business is so much easier than it used to be. You used to have a lot of paperwork and administration, needed to have internal accountants, that sort of stuff. It's a lot easier nowadays. Web is probably the best example of all of these. 20 years ago, if you wanted to launch a big website, say that you wanted to launch something like pets.com, first you had to buy a lot of servers, build your own server park in order to serve the few million users that you wanted to serve to, right? Which meant that you had to pay $500,000, if not more, to kind of do all of that. And then with rack space and renting server space, LAMP, and so on, that became a lot easier, and now it's as simple as getting S3 on AWS or a Google Cloud Platform, writing some HTML for your websites, serving it up, and having it auto-scaled based on demand. Much easier. You can actually start your company for a few $1,000s if you want to and run it from your kitchen table. This, by the way, is a concept that's coined by a guy from Union Square Ventures called Andy Weissman, called the no-stack startup. And the whole point of that is it is so much easier nowadays to start a tech company than, say, 20 or 30 years ago, which is amazing because it means that you can actually focus on the idea and the quality of the idea rather than on the execution if you want to start a company. But is it easier to start a data-driven tech company? And, well, it won't surprise you that my answer is also yes, but let's go through a few steps in order to get there. Because data analytics is actually easier than ever before. I don't know how many of you here used business intelligence or data analytics, say, 20 years ago. How many of you guys are familiar with business objects and with big Oracle databases? Yeah, exactly. So it's no surprise to you that the kind of access to tools that you have right now is much better than 20, 30 years ago, not only in terms of sophistication and ease of use, but also in terms of cost. And it means that even a small company, even if you are a 2 or 3 people a person company right now, you have access to tools that you couldn't dream of 20 or 30 years ago. So that feeds me into what we do at Peak, how we run data science at Peak, what our philosophy is. And the main thing there, I think, is really that we run data science as an internal consultancy, as in we are only 30 to 40 people at peak, but as a data science team, we make sure that we work with everyone in the whole company. We make sure that we know everything that happens in the company. It's a great place to be, by the way, if you want to find out how it is to run a startup, join a small company as a data scientist, because you get access to everything that happens in the company. And I think our job kind of splits into three main functions. It's business intelligence, making sure that we are the eyes and ears of the company, making sure that we know what is happening in the app. Also making sure that we can run descriptive models, predictive models, make sure that we know why people convert, when they convert, maybe think about feeding stuff into the product, which is the second big component. And there you have things like A/B testing, data-driven design, you have dynamic pricing based on conversion models, you have user acquisition with a very data-driven approach. And then probably the third big component is the scientific research part. So we are a brain training company, we have collaborations with Cambridge and with Yale and UCL. We need to make sure that the data we provide in order to do that scientific research is as accurate as possible, and that we help our internal team of scientists to achieve the kind of scientific pieces of analysis that they want to achieve, that they want to focus on. Our stack, just from a kind of technical point of view more, the three big components of our stack is the collection of data, it's the modeling, and it's reporting, as for any small company of our size. We use an event pipeline, means that we capture events in the app, if it's a view screen event or play game event, or maybe it's a transactional event, that all gets stored into our data warehouse that we'll talk about just a bit later. Our modeling is quite simple. It's mainly SQL-based for now, but we're planning to move it to more Python and Spark-based modeling. And the reporting is Mode Analytics, which is a dashboarding tool on top of our data warehouse, R and Python, that sort of stuff. It's really simple, but with all the tools that that people have developed over the last 10 years, it is possible to run a 30 million plus user company just based on this kind of stack. Just a quick word about event collection, because actually it's a super interesting thing that I think people don't think about enough. The reason that we focus on event collection is we want to be able to, for every user that's in our system, see exactly what the user journey is, right? We want to know this user that installed on this day has come from this Facebook campaign or something like that. We want to know how they register, how long it takes them to complete the onboarding funnel, how they then play the first games, how they convert to pro eventually. Because only by linking all of those events together can you actually run sophisticated models on top of that. This is not news for most of you guys, but the important thing to solve that is to actually make sure you all run it into one big pipeline. So our app event data, our server data, but also our third-party data is all ingested by the same central event collection pipeline called SNOWPLOW, where the focus of the SNOWPLOW pipeline and the guys at SNOWPLOW who built this pipeline is not only to serve one central pipeline to make sure that all the events are in the same place, but also to validate your event data in a central place, to make sure that you know exactly what happens to misformed events or to events that are slightly kind of out of the normal scope of the events, that sort of stuff. We run about 100 gigabytes of event data through that per day. And what happens in the data pipeline itself is we validate the data, we enrich the data, we then store it in S3 and load it into Redshift. And this is actually also an interesting point, because actually all of our data, with the 100 gigabytes of data that we store, that we collect every day, it's all still stored in a relational way, which means that our analysts and even our product managers and our user acquisition specialists who can write SQL can all access the data in the most democratic way possible. The message here is, guys, you don't need to kind of use super sophisticated tools if you only use a few tens of gigabytes per day, right? I think this is the message of Martin's talk yesterday as well. If you can do it with Postgres, or if you can do it with this simple tool set, you don't need to go further than that, as long as it suits your purposes. And the rewards of that is you spend less time on maintaining your pipeline, and you spend less time on training your staff in order to use the pipeline in a usable way, right? The data is super structured. This is just an example of what it looks like on S3 and what it looks like in Redshift. Main thing is we can run relational models on top of that. The data modeling itself is actually super simple as well. It's all in SQL. It gets you from the kind of event level data, which is 5,000 events per user per day, gets you to user level and to reporting level. And all of our events, by the way, are kept in a very centralized way. We know exactly what a Facebook invite event is. We have one definition that's shared across Android and iOS and our backend service, which means that you don't run the risk of kind of looking at two different interpretations of data. The reporting is typical stack, I think, mode to do dashboarding on a reporting level, are in Python to do more ad hoc pieces of analysis or to run more sophisticated pieces of analysis. Lovely colors. I mean, we have dashboards feeding into Slack, into Mode, into Google Drive, even if we want to, and so on and so on. That means that we can build a product that is quite data-driven. It means that we have a simple data pipeline that is accessible by everyone in the team, where almost everyone in the team understands what's happening there. It means that our product managers know how they need to think about data-drivenness, that our CEO knows quite well how to think about data-drivenness, and so on and so on. It means we can run A/B tests very easily. It means that we can run smart user acquisition, all this sort of stuff. And the main thing about growth hacking in that way, just on top of the data pipeline, is it supports you in iterating, right? It supports you in being able to easily test things, into being able to easily track things, and so on and so on. You can focus all of your attention of your 2 or 3 people data science team onto doing exactly that, rather than focusing on cleaning data or on building a super sophisticated pipeline. And of course, we also feed that sort of information back into product development. We have coaches inside of the app, all that sort of stuff runs on top of that. So, taking a step back from that, kind of distilling what I think are the fundamentals of our approach there. Number one is really the ability to experiment. The whole reason we built this pipeline, the whole reason we run in this event-driven way, is not only to have visibility on everything that happens in the app in a user-centric way, but also being able to experiment, to run A/B tests where we can come back in after the A/B test is run for 2 weeks and completely change the purpose of the A/B test or the purpose of the analysis or whatever. We don't need to prefix that. We have the flexibility to look at that later as well. But that ability to experiment is crucial. You cannot grow if you are not able to experiment in a way that doesn't kind of completely change the app for every user, right? The whole idea about growth is if you start a company, if you start an app, I can guarantee you that your business proposition will suck in the first 3 months of the app. The reason for that is no one can crack the ideal business proposition at first. Hence, you want to be able to change the business proposition, test out different ways of putting a paywall in place or putting a slightly different upsell page in place or slightly different plan types. But you want to be able to do that without completely messing up the app for most users. If you are not able to experiment in 10% of the users in Australia or New Zealand or something like that, you're not able to change the business direction quite abruptly. And that is I think, a major point. The second point is maybe slightly more interesting because slightly less typical, which is that you need to be able to scale sustainably. And by that I mean, if you remember the growth graph that I showed you in the beginning of Peak, we didn't scale in a kind of very exponential way, but we scaled month over month. We kept scaling, kept scaling, kept scaling. How did we do that? If you talk about sustainable growth, you talk about making sure that if you spend money on user acquisition, which is how most apps grow, that you know exactly what you're going to get in return for the money you spent on user acquisition. And that's exactly what we do. And this is where I kind of want to explain how we do it and why we do what we do. So, of course, we have organic installs, people that install the app because they heard about it on a conference or from a friend or something like that, or because we were featured on the app stores. But because we're not one of the kind of top 10 biggest apps, that is actually a relatively small percentage of our growth. It is about 30–40% of a typical day, but it's not where our major growth comes from. Our growth comes from the fact that we advertise. We advertise Peak on social platforms. We advertise Peak on advertising networks. Google, Facebook, Snapchat, Instagram, those are the kind of places that you do that, where you can advertise to targeted segments, where you know that you want to kind of reach out to people that are interested in brains, that are interested in playing games in a useful way, and say that you spend $4,000 on a campaign that is delivering you 3,000 installs. You know that. You spent $4,000 on a campaign, and Snapchat will tell you, okay, here are 3,000 installs that are generated with your campaign. You measure that using what is called the CPI, cost per install. The CPI then is $1.33. Okay? You're with me. This is quite simple. This is what most people are doing. What we're doing is we're going a few steps beyond that. We are going to be able to predict from these 3,000 installs that are not necessarily going to deliver revenue for the business, We are going to be able to predict 100 conversions from that. And for that, we obviously need a conversion model, but we have conversion models. Remember, we have conversion models that we run on top of the 3 years of event-driven data, which allow us to predict that we're going to have 100 conversions here. And then you're no longer talking about a cost per install, you're talking about a cost per acquisition. So all of a sudden, your baseline, rather than being focused on how many installs you generated with your $4,000, becomes focused on how many revenue-generating users you are generating with that amount of money. And then you talk about a cost per acquisition, cost per subscriber, that sort of stuff, $40. Using that, we then know 100 conversions. We have churn models as well. Remember, we are a subscription business. You pay $2 or $3 a month to access all of the features. We know more or less for demographics or for particular types of users what their subscription behavior month on month is. We call that a churn. Say that you have 100 people registering in month 0, maybe only 70 people remain after month 1, and so on and so on. So you can kind of draw out the churn curve, and you can calculate what's called the lifetime value from that. Lifetime value is then what is the predicted amount of revenue that each of those 100 conversions is going to deliver to peak. And you compare that then, $37 lifetime value with a $40 customer acquisition cost, and you say, okay, this does not match up. This is a return on investment of only 93% or something like that. We are going to stop the campaign because the campaign is crap. We can't really use this right here. Conversely, if your model is slightly different or if your user group is slightly different, you might predict a $40.5 lifetime value, and then all of a sudden your math do check out and you can actually scale up the campaign because, hey, lo and behold, it is sustainable. This is the idea of sustainable growth. You know that you are going to need to spend money on user acquisition, but by doing it in a data-driven way, by from the very get-go developing your whole pipelines to make a conversion model, churn model very possible, you're going to be able to predict this the day after you've run the campaign. And that allows you to know for every dollar that you spend to user acquisition, even if it's $2 million a month or something like that, you know exactly what the expected return on investment is. And that means that you can spend money on user acquisition, that your investors are going to be happy to give you money to do that, because they know that you're able to actually prove the value of that. And this, by the way, is the biggest revolution in advertising for small companies. Bigger companies always used to be able to do something like that on big scales. Small companies are now able to do it not on a huge scale, not on a kind of aggregate level, but on what we call the unit economics level. You're going to look at every unit of your app that is installed or that converts, and you're going to see what the expected value of that is. And that allows you to scale from 0 users to 30 million users in our case. And the third condition for growth, right, is really this kind of culture. We had the good fortune of having a team of founders that was extremely data-driven, that knew exactly more or less what they wanted to get to. And then when I joined about 3 years ago, we built out a team to make sure that that actually happened. But this culture is not something that you should take for granted. And I know people always kind of talk about, yes, we're super data-driven because once a month we look at an Excel report or something like that. That's not data-driven, that's right. Remember that slide I showed about all the reports? That's exactly what is crucial in that regard. If you do not show the value, if you do not show the immediate impact of all of the data points that you're gathering and that you're aggregating, you cannot have a data-driven culture, right? Conversely, if you do not have a data-driven culture right now, right, show them the value. Because only by showing that value can you actually change the culture of data in your company. And again, to reiterate that point, the whole idea of the 2010s is that you're able to do that even in small companies nowadays. Another aspect of culture, of data-driven culture, is in the storytelling. Is in how do you actually take the data, take the brilliant piece of analysis that you did, how can you explain to your founders or to your board or something like that, or any business stakeholder, how valuable it is. And I really like this graph here. So it's made by Florence Nightingale, who was a nurse in the British Army in the Crimean War in the middle of the 19th century. People seem to think that beautiful data visualizations is something of the last 10 or 20 years, but it's not true. This was made in 1858. This is a beautiful graph showing you exactly of all the fatalities, of all the casualties in the British Army in the Crimean War, how much percentage of that in every month was actually due to mitigatable reasons. So just to give a quick explanation, quick word here, the blue line, sorry, the black areas here are deaths caused by bullets or knives, violence in any way. The red is also caused by violence, but in slightly less direct ways. But the blue areas, which are huge, are caused by diseases, or sicknesses, or food shortages, that sort of stuff. And only by visualizing it in this very direct way did Florence Nightingale become able to tell the senior leadership in the British Army at that time to actually fix the clean water in their camps, or to fix the food supply and that sort of stuff. Don't underestimate the power of this storytelling. There was a beautiful talk yesterday about data visualization. This, I think, is the most important aspect of data science in a small business. Being able to do the analysis, sure. I'm sure all of you can make beautiful pieces of analysis come to life, but don't forget about the storytelling. Don't forget about the fact that you need to explain to your stakeholders what it actually means. You can't just give them an Excel sheet. You need to kind of tell a story about it. Also, data is dangerous. I know you guys already saw this graph yesterday, but all of these distributions here, they have exactly the same variance and regression line. Without having a data scientist in your team who can tell the story, this is going to be very confusing to your business stakeholders. It's also a reason why data science or statistics is not just a black box that you can put into R or Python and results come out. No, you need to treat it with care. And another example is here on the X and Y axis, you see the distribution of these points, which is quite random. Only by plotting it like this do you see that there's actually a very clear linear relation with one point of exception here. That's important. That's very important to get the culture right, to tell the story, to make sure that you can actually convince your company that they need to use data to grow. 5 lessons that we learned in our experience that are also quite important there, and some of them are already touched upon. Get the culture right, obviously. Make sure that people know what they talk about when they talk about data-driven growth and that sort of stuff. Make sure if you do event analytics, choose your events very wisely. We spent a lot of time in the initial stages of data at peak, where we were capturing events that were they were not wrong, they were very, very correct. There were events that, for example, captured different screen views, but every screen view was a different sort of event, went into a different table, and you needed a lot of data engineering and data wrangling to kind of get them into the same table and visualize how the flow of users through the app was. Plan your events wisely. You're not going to regret it. Also, storage is very cheap, right? Remember how easy it is nowadays to run data analytics and data engineering, so to speak, on Amazon and Google Cloud Platform and so on and so on. Storage is super cheap. Storage is much cheaper than having an analyst spend days to kind of try and extrapolate what data it is actually that you want to get out of the system. So rather, if being confronted with a choice, store too much rather than too little. Always, 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 and think about validation of your events. You don't want to do event validation in Redshift in your data warehouse at the end of the funnel. You want to do event validation at the very beginning of your event pipeline, because otherwise you cannot trust any data point that comes out of it. This is a thing that we also learned to our own detriment, that we needed to do that. If you have multiple event pipelines, if you don't do a lot of validation and you don't have a centralized event repository, what you're going to find out is that all of a sudden in a board meeting, you're going to have 2 graphs made by 2 different data pipelines that tell a very different story about the same business feature or something like that, right? Unit economics are going to help you to scale sustainably. Without measuring the unit economics, you cannot prove to anyone that your business is sustainable, that your business is scalable, right? Make sure that you think about unit economics in that way. And then, yeah, the keep it simple thing comes here as well, right? Analytics really is a business problem. It's not a technical problem per se. The technicity is rather simple. You have a lot of very sophisticated tools out there that help you solve the technical problems. At the end of the day, it's your job as a data analyst, as a data scientist, to think about the business problem, to think about how to solve those business problems using data. Use data as a toolbox. And that is exactly what I think is the important thing that happened over the last 10 years. That small companies now have access to all of these sophisticated tools. And if you have the right culture and the right mindset, you can actually have a huge impact as a data scientist in a small company. Remember this slide, that data analytics is easier than ever. Question is, of course, what will happen in the 2020s with data analytics in small companies? What tools will you have access to? And I think that the major evolution that's going to happen over the next few years is not necessarily in the kind of technicity of the platforms, or even in the development of even more sophisticated tools. I think the main evolution is that these tools, all of these kind of sophisticated data tools that all of you guys are using right now, are going to be accessible not only to you in tech companies or in data-driven companies, but also to people in classic sector companies, companies like car parts manufacturers or, I don't know, gardening companies, that sort of stuff. But those kind of companies might not necessarily have the access to a data scientist, or might not necessarily have the headcount to hire a data scientist, or even the know-how to know where to find a data scientist. So if you think about data science as this toolbox that has been super powerful for tech companies and to scale tech companies, the future is going to be using data science to scale smaller, not tech companies, companies in classical sectors, that sort of stuff. And that means that data science, rather than becoming this kind of silo role that it might be right now, you have one data scientist in a whole team that does all of the kind of data problems, data science might become more of a tool set that you use if you're a product manager or if you're a project planner or all that sort of stuff, right? It's about having data science accessible to everyone in a company rather than just to one person. And that, of course, means that all of you are in a super nice career track where you can not only help tech companies, but also apply that knowledge to companies in other sectors, companies that do public sector work, companies that do work in refugee work, all that sort of stuff. And that, I think, is the main message of my talk today, that data science will actually be even more powerful in 10 years. And it might not necessarily have to do anything with deep learning. It's just about delivering insight to everyone. So thank you very much for getting me here.
Okay, thank you so much. Right, so we have some questions for you, hopefully. I'm missing my Slido lady. Where did she go? Okay, so give me 2 seconds and I will find them. So I'm going to take one. We don't normally do this, but if we have one from the floor, that would be great. Oh, don't need it. Great. So, first question. To me, growth hacking is just another buzzword like AI, deep data, etc. How would you define what growth hacking is?
Yeah, that's actually a really good question because it is a buzzword, which is why I put it in the title, so all of you guys are here. I think it's really being able to use data to measure everything in your business. That's one component. The second component is use that measurement to iterate, to make sure that you make your decisions in a data-driven way rather than in a kind of intuitive way. And as I said, I think that people have kind of overhyped or almost kind of, well, I think people have overhyped all of that data-driven thinking in such a way that it becomes this kind of thing like, oh, of course we're data-driven because we look at this report every week. No, that's not it. What you need to do in order to be data-driven in your growth hacking is you need to make sure that you have insight that actually actively comes to everyone in the company. And on top of that, the hacking part is exactly what it is, right? It's if you're able in your company to just say, well, I have this random ID to put a red button on the upsell page rather than a blue button, that's hacking. You don't have a big reason to think that, but you can actually experiment with it, see what it is like. And then the other thing is, of course, that you want to be able to use all of your modeling that you have, all of the kind of data-drivenness that you have, not only to describe what's happening, but also to predict what's happening when you add a new thing in there, or when you run a new user acquisition campaign in another country, that sort of stuff. So it's just giving you the ability to do random things and see what sticks to the wall.
Okay, great. So, is there any variable that is surprisingly good at predicting conversion that you were not expecting being so?
Yeah, I'm going to turn the question around. I think what we found to our big surprise is that the factors that determine whether someone will convert to pro or not, they changed massively from age group. As in, we know that We basically have two big age groups, two big groups of users. We have 20 to 30-year-old women that play the app and play the games primarily because they want to have fun, because they're bored waiting on the bus, that sort of stuff. And then we have a user group that's like 55 plus that plays the games because they want to track their mental well-being and want to track their kind of cognitive skills. And those two groups convert in completely different ways. And maybe the fact is that the first group, the young people, are interested in the fun, and the older group is interested in the tracking, right? But for example, the older group needs to kind of look at the upsell screen 10 times, 15 times before they make a decision to convert. The young group kind of does it in day one after installation, that sort of stuff. There's one facet there. I think what is actually quite good at predicting conversion is what type of phone you're on. Depending on if you're on iPhone 8, iPhone 7, iPhone 6, that is a major driver, or at least it used to be the last time we did a big analysis. There's a major driver for making sure if people convert or not.
Okay, great. So, well, I have to say, I know that for me it's about, I'm of an age where it's about working my brain, making it work. Okay, so what kind of model do you use for predicting conversion and churn?
Yeah, so also an interesting question. Actually, we are with a few people of Peak here, so you can talk to us afterwards if you want to find out all the details. But the main message I want to give here is also don't overcomplicate. You can get very good results for predicting conversion and churn by just segmenting your users into demographic groups, into behavioral groups, and then just running historical drivers on that, right? So you can, for example, say, all users in Brazil, 18 to 24, iOS users, they convert in this particular way, or they churn in this particular way. And one of the reasons that is actually quite valuable to us is because we care about the kind of overall average for this particular segment, not necessarily about predicting for one particular user yet. I think our models for more user-based individual conversion and churn modeling are based on random forest and that sort of stuff. Also not the most complicated models in the world, but still quite good at predicting what we want to predict.
Okay. All right, so do you try to model different LTV for different campaigns, depending on how previous similar campaigns have performed?
Yes, actually, we do that. We have an extra kind of, well, we actually have two models to predict LTV that are put in sequence. We have the one model that kind of looks at what the user is doing, what their demographics are, what their segment is, and so on, right? Which is the more general model. And then on top of that, we have little things that actually look at what the type of campaign is that's run, whether it's a Facebook campaign, Instagram campaign, Snapchat campaign. It looks at the historical performance of all of those campaigns and then kind of increases or decreases that lifetime value estimate. And then, of course, we also kind of do different lifetime value estimations based on the plan type, on how much promo we have put into to user or not. Another thing we do in there is we kind of see little evolutions that are happening in the real lifetime value of users that have been in the system as pro user for quite some time already, and we try to extrapolate that. So there's a bit of time series model in that as well, and that's all being fit together into one nice big lifetime value model.
Great, thank you. So the next question that we have, obviously conferences like this, you know, lots of people send people in from large companies,
Yeah.
but it's really about, it's from the startup point of view. And actually, I'd add to that, most probably with that, charities, because obviously they need to be really cost effective. So how do you try to optimize your cloud expenses when, which could be quite high for a young startup, and I'm going to add to that, or charity?
Yeah, really good question, because yes, you have access to a lot of very sophisticated tools, but some of them, because they're run in a SaaS model or because they're run as services, depending on how many users you have, could scale up quite significantly in terms of cost. Which is one of the reasons that we went for the SNOWPLOW event pipeline, which is all based on AWS kind of infrastructure, because it's something where there is a little bit of overhead at the beginning, but then you just pay cost of how much it costs you to run the things on AWS. It's actually quite okay, as in I'm not sure how much I can share with you guys, but it's certainly not more than a few $K per month. This is actually quite extraordinary for the level of sophistication of the pipeline that we're running. Cost effectiveness is a big argument, obviously, for charities as well. think about open source tools that are available as well, because sometimes it might actually be cheaper to run your own Kafka cluster rather than go to the AWS alternative. And other times it might actually be cheaper to just run the pay-as-you-go AWS or Google Cloud model for the things that you do if you factor in engineering time, maintenance time, that sort of stuff. That being said, I think the message is that it's so much cheaper nowadays to run these kind of pipelines than it was only 5 years ago, that this should not be the main argument in not starting a company or not starting to use data in a charity as well.
Okay, great. Thank you so much. Right, so for our last question, how do you validate conversion predictions?
Yeah, not enough. This is the thing, right? It's always a prediction, and we kind of quantify the conversion estimate with levels of confidence that we have. We know more or less from our user acquisition conversion models that some of them are more powerful than others. We look at historical variation, all that sort of stuff. We do look at it on a day-to-day basis at this campaign that we predicted this amount of conversions for 5 days ago. Is it actually getting to that level or not? If it gets to the level, perfectly fine. If it doesn't get to the level, if it overshoots or undershoots, we do correct the model to do that. So the model actually feeds back into itself in that way. We should be fairly accurate by now, as in we have 3 years worth of data to run on top of, right? But this is one of the things that keeps being of concern for us, to kind of get to the level where, rather than being 2% accurate, being 98% accurate rather, we are 99.9% accurate. That's an ongoing thing, because the difference between a 95% accurate conversion model and a 99% accurate conversion model is really the difference between a campaign that's just ROI negative and a campaign that's just ROI positive. And that actually has a major effect, a non-linear effect on how you can scale the campaign, because remember, you can scale the campaigns, put more money in if they are ROI positive, but you have to kind of stop them if they're ROI negative. So that's why it's so important to get to an accurate conversion prediction level. Yeah.
Thomas, thank you so much
No
for
worries.
sharing with us today. We have a gift for you. This is Thomas. Actually, say, it really looks like you.
Oh, thank you very much.
There you go.
It's been a
Thank you
pleasure.
so much. Thank you.